This is Algebra 2 with Trig, 8B.4b. We're going to be evaluating trig functions of any angle. We typically want to think about what our reference angle is going to be, and we can relate that to the first quadrant of the unit circle. I honestly don't particularly think about it as just a first quadrant. I just think about where the coordinates land on the unit circle, using long and short to help us determine if it is root 3 over 2 or 1/2. One way we could handle these is to find the reference angle. We would evaluate the trig function for theta. That would primarily be in the first quadrant. And then we would determine the sine based on the quadrant. In which theta lied in. So here we have our xy axis. We have the four quadrants. We have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. One way to help you remember which trig functions are positive and which of them, they are all, with a big A, they are all positive in the first quadrant. Positive x and positive y. In the second quadrant, we can put a big S. And that stands for sine. Sine is positive in the second quadrant. In the third quadrant, we can put a T that would stand for tangent. It's positive in the third quadrant, and that makes the fourth quadrant, the only one that's positive is cosine. So how can you remember which letters are landing in which quadrant? One way to phrase it is all students take calculus, ASTC. They go in the order of the quadrants. A stands for all, S stands for sine. Sine is positive in the second quadrant. T, all students take, so T is tangent. And C, all students take calculus, would be cosine. But again, I don't primarily think just about which quadrants we're landing in. What I would suggest is to first think or identify where your theta would go. So I guess you could call that what quadrant you would land in. This is negative 240 degrees. So negative means that you're going to be going in a clockwise fashion. It's more than 180, but it's less than 270. So we could make a right triangle out of that. You always make the right triangle with the x-axis. So notice that this right triangle has a short side and it has a long side, long leg. The short leg tells us that it's going to be a half, and because it's to the left, it's going to be negative. The long, the y value, tells us it's going to be root 3 over 2. So you need to think about what is your coordinate at that angle value, at that theta. In terms of a reference angle, the reference angle would be 60. So if you prefer to think about it takes 60 degrees to get back to the x-axis, and then you think about your unit circle at 60 degrees, that's a great way to do it too. I just prefer to think short and long and identify that that's negative and positive. Negative a half, positive root 3 over 2. So tangent, remember, tangent of theta is going to be sine over cosine, otherwise known as y over x. So our y value over our x value, this is a 1/2, not a y, and we multiply this to the reciprocal, and they cross off. The x is negative, so we get negative root 3. So now we'll go on to letter B and pause the video, and you work on this for the next minute, and then come back and we'll walk you through it also. So the first thing we need to do is identify where this angle would be pointing. So this is 17 pi over 6. That's actually off the unit circle. But where is it? One way to do it is just to count individually. So I know that 1/6, and then 2/6, 3/6, 4/6, and 5/6. 6, 6, 7, 8, 9, 10, 11, 12 pi over 6 would be all the way back in a full circle. So the quick way is just to notice that this is larger than 12 over 6, and you can just start from 12. Then you have 13, 14, 15, 16, and 17. 17 is pointing over in that direction. Notice the triangle that is formed. The triangle that is formed has a long leg and a short leg. If you have a long leg and a short leg, you know that the coordinate's going to be negative root 3 over 2, because that's the long number. That's the largest one. And the short is always a half. It's positive if you're going up. So there's your coordinate. Cosecant. Well, cosecant of any angle is 1 over sine. So I need to take my sine and do the reciprocal. So cosecant is going to be 2. So take another minute, solve letter C, pause the video, come back in, check out the walkthrough. All right, so what we're going to start with is identifying where our angle is located. Because it's a negative 225, we're going to go in the negative direction. Negative 90, negative 180, negative 225 is going to be 45 degrees past 180. Now this is going in the negative direction. So if you were to make your triangle, you'll notice that that's a 45, 45, 90 triangle. So your negative root 2 over 2, root 2 over 2. You need to know your coordinates. Sine is the y value. So we're at root 2 over 2. Now we're on cotangent. Cotangent, we're going to do the same practice. We're going to first make our angle. This would be 1/3, 2/3, 3/3, 4/3, 5/3. This is 5 pi over 3. We know that 1/3 is 60 degrees. So if you need to count by 60s, 60, 120, 180, 240, 300, this would be where 5 pi over 3 is. Well, that's going to make a short side and a long side. So your coordinate's going to be 1/2 negative root 3 over 2. If you're doing cotangent, you can either find tangent first and then do the reciprocal, or you could go straight to understanding that cotangent is going to be cosine over sine. So cosine are your x values divided by your y values. And you have to multiply by the reciprocal. So that gives you negative 1 over root 3. And when you rationalize that denominator, you get negative root 3 over 3. All right, go ahead and try the next one. Pause the video, come back and check it out. So for cosine, it directly follows the unit circle. Most all of these do, but the unit circle at 150 degrees has a reference angle of 30. We know that that's going to be negative root 3 over 2 1/2 because it has a long side and a short side. The x is long, the y is short. The x is root 3 over 2, the y is 1/2. Cosine is always going to be the x value. So the answer is negative root 3 over 2. Secant. Well, one thing we know for sure is that secant of any angle is 1 over the cosine. So we need to know what the cosine is at this spot. Well, we got to figure out where this spot is at. Realize that we have a 4, so that means we're breaking pi into 4 equal parts, which is like going by 45s. So there's 1/4, 2/4, 3/4, 4/4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there is our triangle. This is a 45, 45, 90 triangle, so you know your root 2 over 2, root 2 over 2. Secant is the cosine we flipped over. So we will flip over our cosine. Oh boy, we have a radical in the denominator, so we have to rationalize the denominator. And we can reduce the 2's off, and our final answer is just root 2. Negative 225. We've already done the 225s before. They go off in this direction, which is a 45, 45, 90. So our cosine is negative root 2 over 2. Pi over 3. Well, that's way more than 6 pi. That's way more than 2 pi around. So 1, 2, 3, 4, 5, 6 pi would take you a full circle. 7, 8, 9, 10 is going to come down here, which is going to create a 30, 60, 90 triangle. Down low, negative 1/2, negative root 3 over 2. Cotangent is the reciprocal of tangent, so it's not sine over cosine, it's cosine over sine. Which is, excuse me, which is going to give us 1 over root 3. We have to rationalize that denominator, and we get root 3 over 3. And our last one is the secant of 300. 300 degrees is just past 270. So we have a short and a long. Secant is a reciprocal of cosine, so it's a reciprocal of half, so it's 2.